Okay, so I did this a few days ago, so the numbers aren't quite current, but this is what the raw data looks like, and this is that sort of spiky thing that was in the government's graph. I smoothed it out just to make the analysis easier to see more than anything else, because this is just an example. And you might even remember in Mathematica how you do the fits. It's just that function. How do you do fits in Mathematica?
Just fit.
Yeah, so I ask it to fit it to a cubic. And you can see I actually get a reasonable approximation to the data. The problem is when I extend that approximation, we encounter the problem that you mentioned here. So here I have it up to 30 days, and it's a pretty good fit. But the problem is at day 40, 50, and 60, what's happening?
It's just becoming negative and becoming pretty useless.
Yeah, so it's not a great way to predict the future. And it can be wrong in ways that are just, silly. But instead, here, and I'm just going through this quickly, here I'm taking log of the data.
Okay.
And then I'm fitting, and it actually looks like I have a pretty good fit. And now you can see if I extend this, at least I'm not getting nonsense. But here's the problem I want to show you. So at first I'm just taking the last 30 days of data. Up here, I don't know what's on screen or not. And that's what my fit looks like. And then this is what it projects out for the next 30 days. So from the first 30 to the next 30. Okay, so we see our hump that we have here, but then it spikes back up. And that's when I do the last 30 days. So let's do the last 40 days. Pretty good fit?
Yeah, it's pretty good.
Okay. All right, so not too bad. Okay. But going that long ago, there weren't very many deaths. Good, pretty good.
Yeah.
What if I do the last 20 days? What do you think we're going to see here?
I mean, maybe it'll peak too soon and maybe go down before the cases.
Well, I'll be modeling these last 20 data points.
I guess
here.
Those are scattered. You might not get a very good fit.
Okay. Let's see what happens.
I mean, it's an okay fit.
Yeah, it's an okay fit. And then when I try to project that into the future,
it just doesn't work.
So I'm getting at day 40.
Yeah.
So I have for the last 20 days. So 20 days from now, I have 3 times 10 to the 7th deaths.
It's probably not accurate.
Yeah, kind of hope not, right? So even with this correction, when you have, when I do the logarithm to prevent things from going negative and exponentiate it, now some of the other problems with fitting it this way become clear. Do you have any sense of what the problem is trying to fit this to a third degree polynomial? This is a harder question, but I'd be interested in what you think, why this is a bad idea.
Well, I just think that maybe maybe you need to go higher. You need a higher degree polynomial, and the third degree can just change too quickly.
Yeah.
It also has the problem where it goes up, down, and up. And you want something that's going to go up and down and stay low.
Yeah, well, then maybe it'll go up also in the future. But one of the big problems is you're just trying to jam a polynomial into the data,
which might not be a polynomial.
And there's no reason to think that the polynomial would be an accurate representation of the underlying process that's happening. So how does a virus spread?
It's some form of exponential. One person, an X people infect something times X people.
Yeah. So the process is more of the virus is growing at some rate. So instead of trying to fit it with a polynomial, you fit it with these differential equations. So it's a little bit more complicated. But another reason why a polynomial is just not going to be right is the polynomial only depends on one variable, right? Time or the day. And there's no reason to think that the days is the thing that drives it. There's
Mhm.
other more complicated underlying process that drive it. So it's just not really good practice to try to, when you're doing data modeling, to try to force a fit.
Mhm.
You got to know a little bit more about what's going on. But this is neat, and it's a neat calculus example too. All right, good job, man.